Hello, this is the luckiest maths teacher in the world. Now, last time we looked at factorising monic quadratic trinomials. Now we're going to look at factorising non-monic quadratic trinomials, which are a little harder. So remember from last lesson, a quadratic function is something of this form, ax squared plus bx plus c. It's the x squared term that makes it a quadratic. So what we're going to look to do is we're going to look to still factorise, which means write it as something in brackets times something. And we know there'll be x's somewhere in here plus a few other things. So remember, as I said last lesson, that monic means that a, the number in front of x squared, equals 1. So that's what we did last time. So non-monic, what we're doing today is obviously when a does not equal 1. And unfortunately, this makes it a little bit more complicated. We can't use the same ideas that we used last lesson. So here I'm going to be talking about non-monic ones where there is no common factor. You can't divide each term by a common factor. Now to do this, and I'll show you an example in a second, we need to follow 4 steps. So the first step is you have to calculate a times c. So remember, a is just the number in front of x squared, and c is the number by itself. Second thing you have to do is to find factors of AC. So of course by factors, AC is just a number in this case. So to find factors is just the usual way. So what we have to do though is not just find any factors, we have to find factors that add up to B. And remember, B is the number in front of X. So then the third step after we've done that is we split B into these factors. And then finally, you're going to end up factorising using grouping in pairs. So that was the method that I went through a couple of lessons ago. So if you want to watch that video first to refresh your memory, by all means do it. Remember, it's when you have 4 terms, you factorise the first 2 separately and then the last 2 separately. All right, we better do an example so this actually makes sense. So let's try this one. So let's have a go at this one. Y equals 2x squared plus 11x plus 12. Now it's a quadratic because it's in the form ax squared plus bx plus c. So there is an x squared term there. It's non-monic because the number in front of x squared is 2. And it's a trinomial because there are 3 terms. Now we can't use the highest common factor method. I told you that I always want you to see if you can use that first when you're factorising. We can't do that here because 2x squared, 11x and 12, the 3 terms, do not share a common factor. There's nothing that goes into all 3 of those terms. So that's why we need a different method that we're using today. So I'm going to go through step by step how we factorise this. So the first step is to calculate a times c. So a is just 2, number in front of x squared, and c is just the number by itself, 12. So AC is 24, easy as. Now, the second step is that we need to calculate the factors of 24, but we need factors of 24 that add to b. In this case, b, the number in front of x, is 11. So we want 2 factors of 24 that add to 11. So you can go through the process if you don't know them off the top of your head, but they are just 8 and 3, okay? Now, third step, when I say split B, I want to write it as 2 different terms. Then I will have 4 terms in total, and then I can use grouping factorisation by grouping in pairs. So what I do here is I write 11x as 8x plus 3x. I chose 8 and 3 because they are the 2 numbers I got in step 2. So I'm going to rewrite it as 2x squared plus 8x plus 3x plus 12. Now it actually doesn't matter if I wrote them the other way around, 2x squared plus 3x plus 8x plus 12. As long as I'm using those 2 numbers, then factorising by grouping in pairs will work. So then what we do is we factorise the first 2 terms separately. So 2x squared and 8x have a common factor of 2x. So 2x squared divided 2x is x. 8x divided 2x is 4. And then the second two terms, 3x and 12, have a common factor of 3, so it just looks like this. Now, the whole reason that we're doing it this way is we should end up with a common factor in brackets like this. If we don't, then we've done something wrong. So now we're actually just using the highest common factor method. So the highest common factor of this expression here and this one here, the highest common factor there of those terms is x plus 4. So my final answer will be take out the common factor, and then I times by 2x in the first term and 3 in the second term. So I'm done with that. So I have now factorized it, okay? Now I'm going to go through another example, so copy this down if you like. Okay, so let's have a go at this one. Y equals 5x squared minus 18x minus 8. Again, it's non-monic, and there are no common factors of all three terms. So I'm going to go through the same process. First is AC. Now, you have to make sure that you're careful with the minus sign. So here A is 5, but C is not 8, it's minus 8. So A times C is negative 40. Minuses do make things a little hard, I know. So secondly, we have to find factors of negative 40 that add to not 18, but negative 18. So go through the normal factors of 40. Now, we know that one of them has to be positive and one of them has to be negative to multiply to negative 40. So we go through that process, trying the factors, 1 and 40 won't work, 4 and 10, no, we can't get them to add to negative 18, but we can get it to work with 2 and 20. So to get to negative 18, I have to have a negative 20 and a positive 2. Because those two numbers multiply to negative 40 and they add to negative 18. So again, I'm going to split my quadratic term. So 5x squared, I'm going to split b into minus 20x plus 2x. Okay, make sure you keep the signs right. And then, of course, I group in pairs. So the highest common factor of the first two terms I get is 5x, and then x minus 4. And then I take out a common factor of 2, and I'm left with x minus 4. Again, I've got the same bracket in both of these terms, so I know I've done something right. So my final answer, take out the common factor and just write what is left. Okay, and I'm done. One thing I just want to say quickly is that so far, and indeed all you'll do this year, is looking at quadratics that can actually be factorised. Not all quadratics can be factorised. A simple example of one that can't would be, I'll write it in the top right corner, x squared plus 1. That can't be factorised. We can factorise x squared minus 1, but not x squared plus 1. Similarly, we can't factorise, say, 2x squared plus 5. But there are heaps more. Some of them are trinomials. For example, this one here, 4x squared minus 2x plus 9 cannot be factorised using any of the methods that we've gone about. So you don't need to worry about them now. You don't need to worry about ones that can't be factorised. You only need to worry about using the methods that I've taught you. And you can worry about this stuff later. So these ones can't be factorised. Please ask if you have any questions. Other than that, this has been the luckiest maths teacher in the world. Have a great day.